Huh? They're on no,
So, probability. We talked about it, little, predicting the future. We talked about that. And then we got into some probability events, such as the probability of a diamond. Picking a diamond on a deck of cards. Okay? And I'll be animated here. Since I don't have posters for y'all, I'll be animated. There we go. Innovative teaching. All right, so the probability of a diamond would be the same as the probability of a heart. And I think we did hearts last time. And that would be the same. What would it be? 13 over what?
52.
13 over 52, which is 1/4, which is equal to 0.25. Now remember, the best way to put probability is in the form of a decimal. Now when we're dealing with odds, we'll be dealing with fractions, and there's a reason for that. There's a mathematical reason for that. It's easier to compute or calculate the odds against when you're dealing with fractions. It's easier, much easier. Okay? So what if I ask you for the probability of an even number on a die?
So
what would the probability of rolling an even number on a die be?
3 over 6.
3 over 6, which is 0.5.
2 and 4. Oh, I thought you were...
3 over 6, which is equal to 0.5. And a lot of people say, well, Hubert, how do you calculate that? Well, anytime you're asked about odd or even, it's always half of the total. So how many numbers are on a die? 6. What's 6 divided by 2?
3.
3. And that's where the 3 comes from. Or you can just sit there and count them. Where is my even numbers? 2, 4, 6. 3 out of 6. So when you're dealing with probability and you're dealing with the number of times something occurs over the number of times something is tried, you have to know what you're dealing with. You can't just say, oh, a deck of cards, how many cards are in a deck? How many hearts are there? How many diamonds are there? How many face cards are there? You can't do that. You got to know what you're talking about. And I will tell you right now that a deck of cards and a die and a coin, what is the probability? What is the probability of tails on a coin? Well, how many sides do you have on a coin?
2.
2. And how many sides are tails?
1.
So what's the probability?
A half.
What's the probability of having a boy when you have a baby? Well, how many genders are there? 2.
2.
And I be damned if anybody tells me there's another, because when you're born a male or you're born a female. Where they get this other crap, I don't know. I'm talking about physically. When you're born, there's an indicator whether you're male or female. Okay, I'm sorry. All right. And what's the probability of a boy? Well, there's only 2 genders, so one of them's a boy, so that'd be 1, and that's equal to 0.5. So, again, you have to know what you're talking about. You have to know what they're asking. You just can't sit there and go, well, I'm not going to learn a deck of cards. I don't care what's on a die. You can't do that. You have to know what a deck of cards is made up of. You have to know what a die is made up of. You have to know what a coin is made up of. And, of course, you got to know how many genders there are. Okay? Now, what we are doing right now is what we call the theoretical probability. That's what I call it. I don't know what they call it in the book, and I really don't care, because I explain it the way that it's easy for you to understand. You can match it up in your book. There's 2 types of probability. There's the theoretical probability, and I hope I spell that right. Theoretical probability, And then there is the physical probability. Okay? Two probabilities. What we just finished was the theoretical probability. All right? Theoretical is based on mathematics and no actual event. Okay, a while ago y'all told me that there was 13 diamonds in a deck of cards. Okay, Easley, where's your deck of cards? Oconee, where's your deck of cards? How'd you know that? You don't have a deck of cards in front of you. You went off of what? What's
common
in a deck
knowledge,
of cards?
Yeah.
All right? That is called the theoretical probability. I still think that theoretical spelled wrong. Somebody check it for me. All right? Based on mathematics, based on a deck of cards, based on, you don't have a deck of cards in front of you. You do not have a die in front of you. You do not have a coin in front of you flipping it. You do not have, well, I'm not going to say a delivery room where people will be born. You don't have that in front of you. So therefore, you are talking about theoretical, based on mathematics. Okay? Nothing is being done. Now, if nothing is being done in theoretical, did somebody check the spelling?
I did. It's spelled right.
Okay, it just don't look right. If theoretical has to do with no actual event, what do you think the physical probability does? That means I want y'all to interact with me, Miss Riddle. I know she's the only one that's going to interact with me. She's in a pissy mood, so she's not going to talk to me.
It's Shark Week. Leave me alone.
It's Shark Week. I love Shark Week. Shark Week is usually in the summer. What?
No.
What?
Just keep teaching.
What'd you say? It's what week?
It's Shark Week.
It is Shark Week?
You don't have a daughter, do you?
Yeah.
You do?
Yeah.
How old is she?
20, she'll be 21 in March. I have an idea what Shark Week is, but
Well, you're probably right. Shark Week happens once a week every month.
Okay. All right.
Dun dun.
Dang old Eve. All right. So, physical probability would be what? If the theoretical probability is no actual event, then what is the physical probability?
Actual event.
An actual event, something that you try, an observation. Okay? An actual event. Okay? Let's say that you pull out a quarter and you flip it 10 times, and six times out of those 10 times, it comes up tails. Okay? Then that's 0.6, where you said the theoretical probability is 0.5. They don't match. Okay? They don't match. Why don't they match? Well, usually they don't match. Okay? Usually they do not match. And that gives us the big number rule, or the large number rule, or the rule of large numbers. Okay? What is the rule of large numbers? Well, the best way to explain the rule of large numbers, or the law of large numbers, is to give you an example of the rule of large numbers. Okay? Well, just hold on a minute. Okay. There, that's all I wanted to do. I don't know why that was so difficult. All right, the law of large numbers. Somebody find it in your book, if you've got a book. Law of large numbers. Anybody got a book that they can find it right quick?
Yeah,
It'll probably be
somebody's
in that
looking.
first section.
I believe it should be coming.
And 7A, somewhere in there, it should say the law of large numbers.
Oh, Lord.
It'll be a bit more than a paragraph. It should be in purple or something, or blue or whatever. Well, the law of large numbers basically means this. At MIT, there was a couple of students. MIT, there was a couple of students, and these students took a roll of quarters. And they took those quarters and they measured each one of them. They measured the weight, they measured the balance, they measured the circumference, they measured the width, and I'm talking not with a ruler, I'm talking with a micrometer that took it to the 10,000th of a place, okay? So they got all these quarters. How many quarters in a roll of quarters? 40? Thank you, class. Okay, 40 quarters. They took all of those measurements and they took an average and made one virtual quarter and put it into the computer by way of programming. They made a virtual quarter out of all of those measurements. Does everybody understand what I'm talking about?
Yes.
They measured 40 quarters, they took all the measurements, they got an average, and they algorithmically put that into the computer via programming, so the computer had a virtual quarter inside of it. Okay? Then they said, they programmed the computer to flip the quarter. And then they ran a series of tests to find out how many flips of that virtual quarter would it take for the physical probability to equal the theoretical probability. So what is the theoretical probability of tails?
0.5.
0.5. We said that sometimes when you flip a coin 10 times, you get the probability of tails to be 6 out of 10, which is equal to 0.6. So these two are not equal. All right? And these guys at the MIT, they actually did this. Can anybody guess, just guess off the top of your head, how many times it took the computer to algorithmically flip that quarter to get 0.5? Anybody want to take a guess?
100.
Nope. But good guess. Thank you for the interaction. I appreciate that.
200.
Anybody else want to guess? What?
200?
Nope.
Am I higher or lower?
I can't tell you that. Then that would be deduction. But I appreciate the input. It's always good for the class to be, interactive. Makes the class go by a whole lot faster. No coughing in class. Miss Riddle, you need to lay off them Marlboros. They're rough on you, girl. Okay, she's just not going to talk to me this morning.
Right back at you, man. Is it 1,000? Did it take 1,000?
No, I'll tell you how many it took. You're on the right track. But I appreciate all y'all's interaction. Thank you, Miss Riddle. I appreciate everybody else's interaction. Thank you.
You're welcome.
You suck. 100,000. It took 100,000 flips for that quarter for the computer to get to a 0.499999995. Now.
See, I would have guessed that.
I'm sorry, say again?
I said, see, I would have guessed that if you would have given me like a few more minutes. Keep going up.
Then it wouldn't have been a guess. All right. Now, 100,000. Now, what does this have to do with probability and statistics? It has a lot to do with both. Law of large numbers basically tells you if you are ever faced with any probability or statistics in your job, CYA. What is CYA? In the real world, what does CYA mean? Oh, come on, people. You're telling me that nobody in here knows what CYA means. Oh my gosh. Cover your
Ass.
There you go. You knew what it meant. Cover your rear end. What does that have to do with the law of large numbers? Let's say that you are a executive of quality assurance with blah, blah, blah corporation. All right? Quality assurance is where you go through and you check the product that the company is making and make sure you ain't putting out junk. Okay? And you are the director or executive director or whatever, and you make a good amount of money, and you are in office at the headquarters, and blah, 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 wherever, and you are the main dude or dudette having to do with quality assurance. Everybody reports to you as far as quality assurance. Every year, you have to present a report to the directors for budgeting for the next year. Let's say Michelin. Okay, let's say you work at Michelin and you work up there at Crystal Palace right above Greenville, okay, on the left, that big Crystal Palace up there, and you bring it home maybe $125,000 a year. You're a executive, okay, and you get quality assurance reports from all the different companies, and they say to you, well, blah, 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 what does next year look like as far as defective tires? And previously, you kind of slacked off, and you just told the directors at the Sandy Springs plant and the Greenville plant and the Anderson plant, you said, you know, just run me 500 tires and let me know what it does. Okay? Notice, those plants don't put out just 500 tires. Those plants put out like 5 million tires a year. Okay? So you just said, pull 500 tires and tell me what the number is. Okay, they do that. You ran through, you put it in the report and you say, I expect that the shrinkage or the quality assurance report will be that we'll have probably 26% defective tires, which relates to $4.2 million. Okay? And they take that number and you just based it on what? 500 tires from Sandy Springs, 500 tires from Greenville, and 500 tires from Anderson. Everybody with me? The next year rolls around, and at the next meeting they say, okay, here's the numbers from last year. Our defective tires was at 42%, which cost the company $8.6 million. So we were not budgeted. We got a shortage of what, $4.4 million? And what happens to you? Y'all don't know what happens to you when you screw up $4.4 million. Y'all don't know what happens.
I get fired.
You get fired. Okay? What are they paying you $125,000 a year to do? Project for the next year. And what did you do? You dropped the ball because you were lazy. Okay? Law of large numbers says this. If you're going to present probability and statistics, you better make sure you put out enough surveys. You better make sure you survey enough people, enough voters. You better make sure you pull enough tires. You better make sure you do whatever it takes to get those numbers as good as you can get them. That's what it means. Okay? Because the theoretical probability is not going to be equal to the physical probability. Same thing with statistics. So you better make sure you pull enough people and not be lazy, especially when you're making $125,000 a year for Michelin or First Quality or Bosch or whoever. Okay? Now, again, I don't know what y'all's future holds for you, but I do know that you will either see probability and statistics in your job, or you will present probability and statistics in your job. Either way, you need to be aware of the large number rule because it means CYA pretty much, whether you're presenting or whether you are watching a presentation. You need to make sure that the numbers are behind the statistics or the numbers are behind the probability to make sure that it's accurate. Okay? That's what the law of large numbers does. Capiche? Okay. Thank you. Appreciate that interaction. Why don't we just come to class whenever we're in a good mood? How about that? Y'all never come to class. I don't deserve this treatment.
You do fight?
I'm trying to make Monday a good day, and y'all are just fighting me tooth and nail.
It's still better than Friday.
Yeah, Friday was kind of yucky. All right. Here is probability. We already covered some fundamentals. I'm not going to go over some of those fundamentals because outcomes, we talked about outcome. If you flip a coin, when you hit tails, that's an outcome. So you need to, I don't know if you need to write that down. I think most of y'all know what an outcome is. An event. Okay, an event is you flipping the coin. That's the event. The outcome is what comes out of that flipping the coin. Again, I'm not going to insult your intelligence by going over that because I think y'all know what that is. Make sure you write them down, though, in your notes. Outcome and event. Because those are standardized test questions. I'm not going to ask you that on the test, but they are standardized test questions. Next. Okay. Now, this is a question. You don't have to write it down word for word, but this is a question on the test as well as standardized test. They want you to find the sample space and probability of one girl or two girls or zero girls when a baby's being born. It says, consider families with two children. List all the possible outcomes. Possible outcomes is what you call a subspace, okay? It's called a set. It's called sample space. Write those words down. Possible outcomes. The best word is sample space. In other words, what are the possible outcomes of two babies? Well, what are they? Boy, 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 girl, girl, boy, and what? Girl, girl. Make sure you understand that if I said three, it would be boy, 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 girl, boy, 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 girl, girl, boy, boy, and then so on. There's 8 of them. You need to be able to list those sample spaces with children, okay, because that is always going to be a standardized test question, and it's always going to be on my test. So make sure you can make that sample space. And that sample space is right there. How many are in it? 4. Boy, 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 girl, girl, boy, and girl, girl. And the question will be, what is the probability of having at least one girl? So how many outcomes? What's the total outcomes? I'm holding up the answer. I'm holding it up.
4.
4. How many have at least one girl?
3.
Well, actually it's 2. Okay? At least one. Well, one girl, not at least one. One girl. Okay? Because the other one is asked, what is the probability of having 2 girls? And then it would be 1 out of 4. One girl would be 2 out of 4. And then no girls would be what? 1 out of 4. Can you make that yawn a little bit louder?
No. But you're going to have to change that solution eventually because it's going to be a lot of genders according to 2019.
All right, I got one question for you. Tell me what will dictate that gender that you're talking about when they're born.
I mean, it don't dictate anything to me. I think it's a boy and a girl, but people think
I'm just
it's
asking you,
all kinds of
what's going to
things.
dictate that?
People.
The answer from the board.
Oh, okay, so now people are going to decide what their genders are. I think we have lost our damn minds.
Yeah.
Okay? Now, a lot of people say, well, Hubert, you're not open-minded. I'm open-minded to people later on, okay? But when you're born one of 2 genders, period.
Oh, that's the solution.
Okay, so here we go. That's that. And they're telling you what that means right there. I just went through that. So we don't have to do that. What is the probability always fall between 0 and what?
1.
Meaning a decimal. From 0 to 1. And write that scale down. And it's in your book also, but go ahead and write it down if you followed my directions. I told you not to bring a book, remember? I told you not to buy a book. I told you not to bring one to class, didn't I? No, I didn't say anything like that.
The probability.
The probability always falls between 0 and 1. So likely would be 0.75. Unlikely would be 0.25. And so on. Now this is a question. I want everybody to look at that word down at the bottom of that scale. What is that word? Impossible. There is a question on the test or standardized test that asks the question, if something has a 0 probability, is it impossible? And the answer is birth control. Think about it. They always say that birth control is what? 99.9? All right?
Mm-hmm.
Do people get pregnant when they're using birth control?
They can.
Yeah. So always remember birth control with that question. It's a question that's on standardized test, and I'm sorry if birth control offends you. I'm sorry. Get a puppy. But there's a question on a test, on generalized test and on my test, and it says something to the effect, if something has a 0 probability, is it impossible or can it not happen? And the answer is no, it can happen because remember, birth control is pretty much 99.9 blah, 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 but it can happen. So you'll see it on the test, don't worry, but write it down. Just because something is a 0 probability does not mean it can't happen. The probability of something happening is the number of ways an event can occur over the number of outcomes. I told you how many times an event happens over how many times it is tried. We already did. What is the probability of getting a 3 when you roll on a 6-sided die? 1 out of what? 1 out of 6. What's the probability of heads when you toss 2 coins?
Ooh.
Well, that's 0.5 and 0.5. We already talked about that too. There it is, 0.5. But you got to write them out. 1 head when you toss 2 coins. Now that's very important because that's just like saying exactly 1 girl out of 4 births, okay, 1 girl, okay, that's the same thing. Boy, 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 girl, girl, boy, girl, girl, okay? It's the same thing. That's the sample space. This right here is the sample space. How many times do you have 1 head? 2 times, just like 1 girl. So that would be 2 over 4, which is 1/2. A 3 would be 1/6, which is whatever 1/6 is. 0.17, I believe. Anybody got questions so far? This should be like a review for most of you because you've had probability in high school. There are 52 playing cards in a standard deck. There are 4 suits, known as hearts, spades, diamonds, and clubs. Each suit has cards for a number suit. We've already covered this. Okay? What is the probability that the card you pick is a spade? 13 over what?
52.
Which is 1/4, which is 0.25. Okay, write this down. Here's 4. I've already went over 2 and 3. You need to write that down because it's easier for you to have it written down somewhere than it is for you to actually think it up. You need to have 2 children, 3 children, and 4 children. Here's 4. And that way you won't have to try to get it in your head. Write that down because that's going to be on the test, whether it's a standardized test or whether it's my test. It's a question on both. You got it written down? Oops, sorry. What is the probability of having 2 girls and 2 boys? Well, 2 girls and 2 boys. 2 girls and 2 boys. Here's, let's see. 2 girls. Here's 1, 2, 3, 4, 5, 6. 6 out of how many? Okay, they got it right here. 6 out of 16. There it is right there. So that's a good test question. It's a good homework question, and it's a good standardized test question. So I'm going to leave it up there and let y'all write it down because that's a good one. Everybody got it?
Yes.
All right. I was looking to see, because I don't want y'all going into convulsions. Same thing. They're giving you the same thing. I'm not going to. Relative frequency. We already talked about that. That's the number of times something happens over the total. We talked about that with the first start of statistics. I'm not going to go over that again. Fair coin test. Suppose you repeat it too. Compare the relative frequencies. Okay, 0 out of 22 would be 0. 1 out of 51 would be, I don't know. You'd have to do that in the calculator. What's 1 divided by 51? and then 2 divided by 27, and then compare which is the best probability. Well, I can tell it's going to be between B and C because anything is better than what? What's 0 divided by 22?
0.
0. So anything's going to be better than that. So what's 1 divided by 51?
0.02.
And what's 2 divided by 27?
0.07.
Okay, it sounds like to me that you got a sorry coin. Why? Because what is it supposed to be? What's the mathematical probability of a tails or heads? What is the mathematical probability?
Half.
0.5. And you're getting 0, 0.07, and what was the last one? What's 2 out of 27?
That was
0.07.
Okay, so they're all around 0. So what does that tell you about the coin? I asked the question last.
I mean, it's not really good. It's not.
Okay, what does 0 compared to 0.5? What does that tell you about the coin? Okay, y'all flip a coin. 22 times, 51 times, and 27 times. And it comes up to be 0% heads or tails, and mathematically it's supposed to be 0.5? What does that tell you about the coin? Something's wrong with the coin. Do you have a reason to suspect that the coins are unfair?
Well, yeah,
yes or no?
Not mathematically correct. Yeah.
They're not. They're unfair. What if you rolled a die, and every time you rolled a die, it came up to be 5?
Probably have a magnet in it.
Yeah, it probably has something wrong with it. Okay? There, we just did that, but we did it the shorter way. I'm not going to worry about that. That's not a good test question. There, look at there, theoretical probability. Based on the assumption that all outcomes are equal likely. You know the deck of cards, you know you don't have it in front of you. Okay, a relative frequency probability based on what?
Observations.
And?
Experiments.
That would be you flipping the coin. It would be you rolling the die. It would be you picking the card out of the deck of cards. That is theoretical. This is what? Physical. But hold your pinky up and you can call it the relative frequency probability. What is a subjective probability? What is anything subjective? And that's a good word to know, especially for interactions and future tests. Subjective. If something is subjective, what are you throwing out the window? Does anybody know? Okay, tell me if you know, but you just don't want to talk to me, okay? Or if you don't know. Tell me one of those two things so I'll know what I'm dealing with.
I really don't know.
Okay, that's good. That's good enough for me. Subjective is when it's right here. It's coming from where?
Inside. Or it's a
Coming
personal
from your
experience.
heart. It's coming from the way you feel. Write that down. Yeah. Subjective is something that you feel. Subjective throws science and what? Math out the what? Window. All right? When you say, you know what? I think everybody at the Easley campus is stupid. Okay? That's being subjective. I'm not basing that on anything. Okay? Or I could say everybody at the Oconee campus is a worthless loser. Okay, that would be subjective because I don't have any evidence of that. So a subjective probability is based on what? Experience or intuition, but subjective is usually based on something that you feel, your opinion. Is subjective good in probability?
No.
No. Okay. I'm 100% certain that you'll be happy with this car. That sounds like a car salesman. Never trust a car salesman. Sorry. Subjective. Based on government data, the chance of dying in an automobile accident during a 1 year period is about 1 in 8,000. Subjective or analytical? It's analytical. You're basing it on, I don't know what they call it, relative, yeah. The probability of rolling a 7 with a 12-sided die is 1/12. That sounds pretty analytical. Okay, the complement. Let's see what time it is before y'all go into convulsions. Okay, let's leave off on the complement. This is the complement. Let me see if they tell you it's the complement. They're not calling it the complement. Why aren't they calling it the complement? I hate this book. All right, write complement down. It should be in your book somewhere. This is the complement. What's the complement of male?
Female?
Female. What's the complement of black?
White.
What's the complement of true?
False.
False.
What's the complement of 0? 1. Binary system. What's the complement of guilty?
Innocent.
Not guilty.
Actually, it's not guilty. Because if you're innocent, you never go to the courtroom. I'll give you an example. Let's say Miss Riddle works at Papa John's Pizza.
Yeah.
Okay? And let's say Miss Anya Sador is her roommate. Okay? And they work at, Miss Anya Sador, she don't work anywhere, and she bums off of Miss Riddle. And she don't even have a car, she don't have a job. But one night, while Miss Riddle is working at Papa John's, she's like the assistant manager wannabe, and she's like telling everybody what to do. And she's given the keys to the shop that night. And Miss Anya Sador says, Miss Riddle, I need to borrow your car. I've got to go somewhere at 9 o'clock. Well, Miss Riddle is working from 5 o'clock till 1 o'clock in the morning. Okay? And Miss Anya Sador gets a ride up to the Papa John's, and Miss Riddle gives her a car, and she goes off, and Miss Riddle don't hear anything about it. She brings the car back. Miss Riddle goes home. The next morning, law enforcement shows up and takes Miss Riddle into custody. Okay? Miss Anya Sador went and stole an ATM, chained it up and stole it, and they got the license plate off the car and come and got Miss Riddle. Okay? Will Miss Riddle ever go to court?
Yeah.
No, she will not.
Huh?
Oh, wait, what?
Miss Riddle will never go to court because where was she?
Oh, I was working.
And how many people work at Papa John's?
Enough to vouch.
And what do they also have in any business now? What do they have inside the business, inside the building?
Cameras.
Cameras. And they also have cameras at the ATM. So, will she ever go to court?
No.
No. But they'll come get Miss Anya Sador because Miss Anya Sador was smiling on the camera when she was chaining up the ATM. Okay. Why did OJ go to court? He said he was innocent. Why did he go to court? Why did he go to court? He didn't have a what? Y'all do know OJ, right? The guy that killed his wife. I'm sorry, he was innocent of killing his wife.
Yeah, that football player?
Oh, yeah, exactly. Why did he go to court if he was innocent? Because he did not have a what?
Alibi?
License, maybe?
He did not have an alibi. He did not have an alibi. If somebody can't put you somewhere during a crime, you're going to court because you're not innocent. Okay? Now, what does the court prove? Does the court prove that you're innocent, or does the court prove that you're guilty or not guilty? Well, if you're innocent, you don't go to jail. You don't even go to court. So what does it prove? Guilty or not guilty? So the complement is what makes up the whole. All right, we'll stop at complement, and I'm going to stop the recording, but I need to tell y'all something.